Welcome to Engineering Scale Models. I'm Jason, your host, and I do models. How is everybody today? In a previous video, I talked about using a rotary encoder like this to send a data and a clock signal as a clock pulse. Normally, when you turn a rotary encoder, the A signal goes low and then the B signal goes low, and depending on if you turn it clockwise or counterclockwise, what goes low first determines the direction. So I thought to myself, if I invert the signal, could I use one as a data and one as a clock to push data through a shift register? Because if I go to the pad, I think I can draw this out here. Okay, so you have, this is over exaggerated. But we'll say this is one direction, and we'll say this is the data and this is the clock. If the clock rises and data is low, it'll send a 0, and then if it raises again, it's 0. So if it's moving in, say, this direction, it'll clock a 0. But if it's moving in the opposite direction, that one's, and then on this one the clock comes after in that direction, so that's where the clock is. So now when the clock signal goes high, data's a 1. So my thinking was on this, you click it one way, you send a 1. You click it the other way, you clock a 0. And it works. And if I turn this on, I have a shift register hooked up here. And into the shift register, I have the clock input going into serial in, then I have the clock going into the clock input. And then I have the serial in port is the data. It's going through an inverter, so it's sending positive pulses instead of negative pulses. And then as I turn it, it will shift. But the only problem is, if I move it fast, it'll do things. I move it backwards, it'll do things. And what I'm getting is I'm getting a lot of bounce in the contacts. And currently right now I'm using just a standard TTL inverter chip, and what I found is I have a lot of bounce in the circuit, so it seems to work sometimes, and then I get this bounce and I get issues with the current shifting. But let's take a look at this bounce on the oscilloscope, which I should have turned on. So we'll go to this view. That's my meter. There we go. There's the oscilloscope. Let me dig out the leads here. Sorry guys about not having the camera in the right spot first. Okay, so I'm going to plug in my yellow channel, which is channel A, into my negative. And then I'm going to get a lead here. And I'm going to come off of this inverted, A is clock, so I want to come off of this inverted signal here. So, as you can see, the signal's pulled low. And let me see here, let me put it into single. Why is it not? trigger. Why is this at... Okay, so... Why am I having such difficulty getting this to trigger? I can get it to trigger. I can't get it to trigger single. Get it normal. Okay, now there is a good look at the signal. Let's zoom in here, and you can see at 102 microseconds it is super bouncy. So you can see as one time it goes up, down, up, down, up, down, up, down, and that's the bounce in the switch. So you can see it right there. There's low right here, and then there's high, and you can see one click gives me that much bounce in the circuit. So if I can't get it to trigger one time. I have the hardest time figuring out this trigger mode here. If anybody wants to leave a comment on how to trigger this. I got rising edge trigger, and it is, let's go to trigger setup, slope, rising edge, edge type edge, slope rising. Let's type, let's do, see if we can catch the whole, no, not slope, not slope. I want, it's the thing with this, when you push the button you move it. Limit range. I'll have a limit range. Positive. Source channel 1. Oh, the trigger limit was too high. Let's see if this works. Okay, so let's go to auto again and see if I can catch. See, I can catch the pulse, but I don't know how to stop it on the pulse. Let's see if I can go back to history. No. Yeah. Let's try normal. No, I don't know. I'll have to figure out how to work the trigger on this. But as you saw the switch debounce. So I am going to work on getting rid of that debounce with a RC circuit. And instead of this inverter, I believe it is a 74 LS04. I'm going to swap that with a TTL hex inverter with a Schmidt trigger to kind of soften out the waveform from the charging and decharging of the capacitor in the RC circuit. So I'm going to come back when I do that and see if we solve this problem. Hey guys, I'm back with another look at my using a rotary encoder as a data and clock signal for a code crack game. And as you can see, my lights are cleared here. Let's just dim that a little bit. And I'll show you here. If I come over here and I click it this way, let me turn it on first. If I click it this way, I can cycle in a 1. And if I click it this way, I can cycle in a 0. So now I can very easily do 1s and 0s. Very simply, and I'm going to end up having a master code over here. And to implement this, I am using a 74LS14 inverter with a Schmidt trigger to invert the clock signal. The clock signal is going through an RC circuit. I talked about that in the earlier part of the video. And then that is coming to a different chip now. I was using a 595 shift register before. Now I'm using a 74LS164. It is a 8-bit parallel out serial in. It has a AB serial in connection, 8 output ports, and a clock signal and a clear signal. Clear is tied high permanently because it's active low. And now I can, input codes with no hidden bit in the register. So that is where we are on this code crack game at this point. So as you can see, let me turn this off so you can see it better. Yeah, that's better. And then I can just very carefully turn this and input any code, and it's very responsive. So I got some more plans. I'm going to make a master code section with the blue lights, so you have to try to match the code, and then it will evolve from there. But this is going to do it for this video on using the rotary encoder as a clock and data input to use it on a shift register. I'm going to be making another part on how this evolves into a more elaborate undertaking. So that is going to do it for this. You can visit me at these social media links. Support me on Patreon for more cool projects. Also, a GoFundMe is in the description. Thank you and have a fantastic day.